In this video, we're going to go through acid-base reactions. Our essential question is, how can we predict the products of an acid-base neutralization reaction? So let's begin by defining what an acid neutralization reaction is. So in this reaction, we have an acid and a base. They're going to react, and the reaction always produces a salt, which is an ionic compound, and water every single time. So that's an acid-base neutralization reaction. Well, what's an acid and a base? Well, in simple terms, an acid is going to be donating a hydrogen ion to our water, and our base is going to be donating a hydroxide ion to our water. Okay, so the hydrogen from the acid, the hydroxide from the base will combine to form water. What's left over is a salt, which is an ionic compound, which forms from our cation and our anion that are left over from our acid and base, kicking out hydrogen and hydroxide. So examples of salts are sodium chloride and potassium sulfate. Okay, so here are the steps. Number one, we're going to identify the acid and the base. Again, the acid donates the hydrogen ion, the base donates your hydroxide ion. If necessary, we'll write out the chemical formula for the acid and the base. On the product side, we're going to combine the hydrogen ion from the acid and the hydroxide ion from the base to form water. The ions that are left over will then form our salt. An important step in this process is to make sure that the charges balance, and then finally, balance the entire equation. We want to make sure the atoms on the reactant side equal the atoms on the product side. So let's look at this example. So we have hydrochloric acid and potassium hydroxide. In this reaction, our acid is going to be our hydrochloric acid, and our base is going to be our potassium hydroxide. I know this because, look, I've got a hydrogen right here, and I have a hydroxide right here. So the hydrogen from the hydrochloric acid and the hydroxide from the potassium hydroxide will combine to form water. And then the ions that are left over are going to form our salt. So I have an anion, I have chlorine from HCl, and then I have potassium from KOH. Those are going to combine to form our salt. So remember, we always write our cation first. Oops, almost wrote the same thing twice. Potassium chloride. Great. So there's our reaction. We want to make sure our charges balance. So potassium is +1, chlorine is -1, so I don't need any subscripts on my KCl. Now we're going to balance the entire equation. So I'm going to list out all of the pieces. I'm going to do that on both sides. So on my left-hand side, I have 2 hydrogens. Be careful, make sure you count it from both the acid and the base. I have 1 oxygen, 1 chlorine, 1 potassium. On the right-hand side, I've got my hydrogens grouped together this time. 1 oxygen, 1 chlorine, 1 potassium. Oh, would you look at that? It's already balanced. Fantastic. Those are our favorite types of equations, where they balance themselves. All right, let's move on to another example. Okay, in our second example, we have 2 compounds. And again, I have hydrogen in our sulfuric acid, and I have hydroxide in our sodium hydroxide. So they're going to combine to form water. And then my ions that are left over are going to be sulfate and sodium. Okay, sodium is +1. So here we are going to need to balance the charges. So I'm going to need 2 sodiums to balance out with my sulfate. Okay, now we balance the whole thing. If your polyatomic ion exists on both sides, I'm going to write it twice. Now notice I have oxygen listed twice. I have oxygen by itself, and then I also have oxygen in the sulfate. Okay, so I'm going to treat them separately. So I have, let's see, I have 3 hydrogens on the left-hand side. I have 1 oxygen by itself. Okay. I have 1 sodium, and I have 1 sulfate. Okay. We're going to pretend like this 2 is not there. I think I copy and pasted that and made a mistake. So we're going to pretend like it's not there. Let's see. We have 2 hydrogens, 1 oxygen, and 2 sodiums, 1 sulfate. Okay. Yeah, so let's see. Let's do the hydrogens last. Okay. So now we're going to put a 2 here like we had before. Okay. So 2 times the 1 sodium makes that 2. 2 times our hydroxide. So be careful here. We have 2 hydrogens here. If I multiply this, that will give me another 2 hydrogens here. So that'll give me a total of 4 hydrogens and then 2 oxygens. Okay. To balance the right side, I'm going to put a 2 right here. That'll multiply my hydrogens to 4. That'll make my oxygen 2. All right, there we go. Hate it when I give the answer beforehand. All right, let's look at this one here. So here's our acid. Here's our base. So I'm going to have water. All right, I have NO3. NO3 is our anion. NO3 is -1. And I have calcium. Calcium is +2. So I'm going to need 2 nitrates to balance with my calcium. Now we balance the whole thing. All right, so we have 1 hydrogen in HNO3. I have 2 hydrogens here, so that's going to be a total of 3. I have 1 nitrate, 1 calcium, and I have 2 oxygens, because remember, this is multiplying to each of those here. On the right-hand side, I have 2 hydrogens. I have 2 NO3s. I have 1 calcium, and I have 1 oxygen. Okay, so I'm going to balance hydrogen and oxygen last. So let's start by balancing our nitrates. So I'm going to squeeze a 2. Oof. Well, let me do that. There should be a 2 right there. So 2 times the 1 hydrogen makes it 2. I also have the 2 hydrogen over here, so that'll make this 4. I get my 2 nitrates. Okay. Now on the right-hand side, my oxygens aren't balanced. My hydrogens are also not balanced, so let's put a 2 here. That 2 will go to the hydrogen and the oxygen. 2 times 2 is 4. 2 times 1 is 2. Balanced. Oh, I did it again. Don't see anything right there. Okay. Definitely have to go back and fix that before class today. All right. So we've got hydrogen and we have hydroxide. So we're going to form water. And we have phosphate, PO4. PO4 is -3. And then I have potassium, which is +1. So I'm going to need 3 potassiums to balance with my phosphate. Split it in half. Okay, so we have 4. I've got 3 here, and then I have another 1 right here, so that's 4. Oxygen's by itself. I'm just counting this one right here because the other oxygen is part of phosphate. 1 phosphate, 1 potassium. On the right-hand side, I have 2 hydrogens here. I have 1 oxygen, 1 phosphate, and 3 potassiums. All right, let's balance our potassium first. Okay, so we'll do hydrogen and oxygen last. So now I'm going to throw that 3 in there. So that'll make this 3. So I'm going to end up with 3 oxygens. Now, hydrogens, remember I have my 3 from right here, and now 3 times 3 makes that a total of 6. Okay, so I'm going to throw a 3 in right here. 3 times 2 gets me 6. 3 times 1 gets me 3. And that's balanced. And that is how you do acid-base neutralization reactions.